How are we going to differentiate x to the power x? So the first thing that you have to do when you see these types of questions, you have a variable at the bottom and you have a variable at the base. You have to first know that this is your function, which is y is equal to x to the power x. And now if you see the presence of this, you have to multiply both sides by natural log, right? Natural log of y is equal to natural log of x to the power x. Now the next thing I have to do is you have to obey the laws of logarithm. If you have a power here, it's going to come in front. So that is going to be natural log of y is equal to x natural log of x. From here, you can differentiate both sides. D dx natural log of y is equal to, that means that this place 2 is differentiable. That's going to be x natural log of x. So if you if you differentiate natural log of y, what are you going to get? 1 over y dy dx, because you are differentiating with respect to x. And if you this is a product, right? So we are first going to use the product rule over here. So we maintain this, we differentiate that. So when we maintain our x, we still get an x. And when we differentiate natural log of x, what are you going to get? If you differentiate natural log of x, you are going to get 1 over x. But if you differentiate natural log of u, because you want it in respect to what x, is going to be 1 over u du dx. Okay, so this part is going to be this part is going to be natural log of 1 over, x is going to give you 1 over x. Now since we maintain this, now we differentiate this and we maintain this. That's going to be natural log of x. So 1 multiplying natural log of x. From here, I'm going to get 1 over y dy dx is equal to, this can cancel that, leaving you 1 plus 1 natural log of x can be written as natural log of x. So we are finding dy dx, so we can multiply it through by y. So you multiply here by y and we multiply here by y. This is going to cancel that. So dy dx is equal to y multiplying 1 plus natural log of x. And remember that y was x to the power x. So you are going to insert it over here. So dy dx is equal to x to the power x multiply 1 plus natural log of x. So this is your answer when you are differentiating a variable. So you can use the same method to solve different type of questions. So let's try more questions on this. Let's assume we are told to differentiate x to the power cos x. So how are we going to do this? So since we have a variable here and here, that means that it's going to be like the first one. We are going to use the same steps and the same procedure. So we know that this is a function giving us x to the power cos x. The next thing is that we are going to multiply both sides by natural log of y. Natural log of x to the power cos x. This is going to come in front. So that's natural log of y is equal to cos x multiplying natural log of x. Now we are going to differentiate both sides. So if you differentiate natural log of y, you are going to get 1 over y dy dx. Then now here we use the product rule. You are going to first maintain 1, differentiate 1, then the vice versa. So let's maintain cos x first. When you maintain cos x, you are still going to get cos x. Then you differentiate natural log of x. Good. Now we can differentiate cos x. When you differentiate cos x, you get negative sine x. and we are going to maintain natural log of x. So multiplying natural log of x. So from here we can say 1 over y dy dx is equal to our cos x over x minus, over here it's now left with sine x multiplying natural log of x. Okay, so we are going to use the same rule. So first of all, we are going to multiply here natural log of x to the power sine x. This goes there. So sine x multiplying natural log of x is equal to natural log of y. The next thing is you differentiate. So that's 1 over y dy dx is equal to, now I'm maintaining this first. So I maintain this, I differentiate that. Then now I differentiate this. That's the product rule. The product rule is if you have two functions u and v, and you want to differentiate them, then v du dx, you see they maintain v over here, they differentiated u, plus they maintained u and differentiate x. So that's what you get when you differentiate u dot v. So this is the product, we are applying that over here. So sine x was maintained, we differentiate natural log of x, then now we differentiate sine x, so that's going to give us cos x, then we maintain this one. Okay, so dy dx is equal to y into brackets over x plus cos x natural log of x. So our dy dx is x to the power sine x multiplying sine x over x plus cos x natural log of x. So this is our final answer. We are given a function f of x is equal to x squared sine x, and we are told to find f prime of x. So how are we going to solve this question? F prime of x, we are going to use the product rule, because here we can take x squared as u and we can take sine x as what? V. So we can maintain x squared first. So when we maintain x squared, then we differentiate sine x. What's the differential of sine x, or the derivative? That's cos x, plus, now we differentiate this one, which is x squared, that's going to give us 2x, then we maintain this, so that's sine x. So x squared cos x plus 2x sine x. Can we factor something out? Okay, so x can come out, or x can be factored out, leaving us to x cos x plus 2 sine x. So this is the final answer. Okay, what about the givers? What about you are given y is equal to sine x cube? How are you going to do this one? Okay, so in this question, we have to use the chain rule. So we can say that let your inner function u, I mean x cube, be u. So now if it is u, you know that du dx, that's when you are differentiating that inner function, you are going to get 3x squared. Then now we represented the x cube with u, so we have to show that. So that's y is equal to sine u, right? So when you differentiate sine u, we are going to get cos u. So from here, we can state the chain rule, that's dy dx is equal to dy du times du dx. right? So our dy dx is equal to, our dy du is cos u. Cos u x is 3x squared, so 3x squared. So that's going to give us 3x squared cos u. So what was our cos? Our u. Our u was given to be x cubed. So our final answer is going to be 3x squared cos x cubed. Okay, what about this question? Y is equal to tan e to the power 5x. How are we going to do this one? So we are going to use the same way that we used this method, or the same method. So we can say that let our inner function u be equal to e to the power 5x. Then now we differentiate that. If you differentiate e to the power 5x, what are you going to get? So if we are differentiating e to the power x, that still gives us e to the power x. So if we are differentiating e to the power 5x, there is a simple rule that we take. First, we rewrite the whole thing again. That's e to the power 5x times, you differentiate the exponents, so that's going to be 5. Then you multiply it by the natural log of what is over here, that's the base, or this variable, that's e. So this is how we differentiate functions that have the variables to be the exponents, but what's carrying the variable to be a number. So over here we got to know that the base for natural log is e. So natural log of e is just 1, leaving us 5e to the power 5x. We will try more questions on that. So when we come back to this problem, if we differentiate e to the power 5x, that's going to give us 5e to the power 5x. Then now we have y is equal to tan u. If you differentiate tan u, what are you going to get? So if you differentiate tangent, tangent, you are going to get secant square. So that's sec square u. So now we have everything we need in our chain rule. So we can say that dy dx, we can state our chain rule is dy du times our du dx. So that's going to give us our derivative. Our dy du was sec square u. So that's sec square u multiplying our du dx was 5e to the power 5x. So what do we get as our first derivative? So that's going to be 5e to the power 5x multiplying our sec square u. Our u was given to be e to the power 5x. So this part is going to be e to the power 5x. So this is the final answer. So let's try more questions on these types of questions. So what about y is equal to let's say 2 to the power x? So how are we going to do this? So as I said, if you see a function that a number or a constant number is carrying the variable as an exponent, what we have to do is we have to follow the rule that we just applied over here. So for this one, we are going to get dy dx is equal to, first we write the whole thing, that's 2 to the power x. Then now we differentiate the power, that's 1. Then now we write the natural log of this, so that's natural log of 2. So dy dx is equal to 2 to the power x natural log of 2. Okay, so what about you are given y is equal to 4 to the power x? So the same thing, so that's dy dx is equal to 4 to the power x multiplying the derivative of the power, multiplying our natural log of 4, which is dy dx is equal to 4 to the power x natural log of 4. What about a function y is equal to sine 2x over x square? This is a totally different one, but still the same method, still the same principles. So how are you going to find the derivative of this? So notice that this function has been given in the form of y is equal to u. Sorry, my pen is y is equal to u over v. So it's a quotient. So in order for us to differentiate this, we have to use the quotient rule. Okay, and the quotient rule states that if you are having a function u over v and we want to differentiate that, that's going to give us v du dx minus u dv dx all over our v square. So what this simply means is that we are first going to take the how do you call it, the denominator. You get it? Then we maintain it and differentiate the numerator. Then for the next one, we rather what, maintain the u and differentiate that. So let's do that together. So our derivative y prime is equal to our v is x square. Look, that's our x square. So that's x square. Then our du dx, which is our sine 2x. So when we differentiate sine 2x, what are we going to do? That's going to be 2 cos 2x. How did we get this 2 cos 2x? So we can perform this one somewhere. We have sine 2x and you want to differentiate that. So you can say let u be equal to what? 2x. Our du on dx is what? 2, right? Then now our y is equal to sine u, right? If we differentiate sine u, we get cos u. So now dy dx is equal to what? Dy du, which is our cos u, times our du dx, which is our 2. So that's going to be 2 cos our u is 2x. So you can see that a simpler way of getting this is if you have y is equal to sine ax, the derivative is the same as what? A sine ax. Okay, it also works for other trig functions. So if you have y is equal to cos ax, the derivative is going to be a note that over here, if you differentiate cos, that's negative sign. So that's going to be a, okay, multiplying negative sine ax, multiplying negative sine ax. So that's negative a sine ax. So we just have to know the trend. Okay, so over here we get this minus our u is already sine 2x multiplying dv dx. If you differentiate this, that's 2x all over our x square, so we are going to square that. Okay, so that's going to be, let's rearrange this or rewrite this very well. We are going to get 2x squared. This time this is 2x squared cos 2x minus, what do we have over here? That's going to be sine 2x multiplying 2x all divided by x to the power 4. So our y prime is going to be um can we do something over here? We can factor x out because there is x over. In fact, we can factor 2x out, right? Because we have 2x here and we also have 2x squared over here. So that's 2x coming out, leaving us with x cos 2x minus, over here our 2x is also coming out, so that's left with sine 2x all over x to the power 4. So you can see that over here x can divide this, leaving 3x is over here. So our y prime, which is our final answer, is going to be 2. You can expand this part to the 2 or you can leave it outside, any of them. So that's 2 multiplying x cos 2x minus sine 2x all over x. So this is the final answer. Okay, so what if we are given x cubed plus y cubed is equal to 6x plus y? How are you going to do that? So notice that this equation has both x and y terms. So we are going to apply the implicit differential way. So first we differentiate x cubed, that's going to be 3x squared. We differentiate this one, that's 3y squared. And because it is y, we are going to attach dy dx. Then now we differentiate 6. Since it's x, we still write 6 over here, plus. Now you differentiate y. So that's going to be dy dx. So this you can group the dy dx on one side. So that's 3y squared dy dx minus dy dx is equal to 6 minus 3x squared. We can factorize dy dx out, so leaving us with 3y squared minus 1 is equal to 6 minus 3x squared. So when we divide through by 3y squared minus 1, we are left with our final answer. Okay, so this is our answer.